Alright guys, so today we are going to look at chapter 11, finishing up. So in the last video I stopped here, we're talking about semi-conservative replication in DNA. Okay, if you guys remember back on this video here, okay, or on the slide here, we showed how it kind of replicates on this pattern right here in the middle. Alright, so what we're going to get into today is the actual mechanism of how DNA replicates in this semi-conservative pattern right here, where this is the original strand of DNA up here, and you get two new strands, one off the original and one that actually gets written in. Okay, so the very first thing that happens when DNA replication occurs is you get this little molecule here, and it kind of looks like a triangle or like a top. And it's called DNA helicase. Okay, so what this DNA helicase does is it comes right down the middle here, and it starts unzipping DNA right down the middle. I mean, it looks almost like a zipper on a jacket. So it comes down and it starts unzipping everything. Okay, and when we unzip, we basically cut this right down the middle, okay, and we'll have two fragments on either side, which you can kind of see here. This one, it just happens to have a little bend in it, okay. Now one of the first important things that we got to do is we need to make sure that the DNA doesn't bind again right after DNA helicase comes through and unzips it, okay. So what we have are these little single strand binding proteins on the outside of the DNA here, okay? So those single strand binding proteins are going to bind with each strand, okay? And it's going to prevent these guys from bonding back together again, okay? So once we have these two strands now isolated, okay, it's time for us to go ahead and start writing in the new DNA, okay? The easiest one that we have is the leading strand of DNA, which is this one here, okay? And what's basically going to happen is there a molecule called DNA polymerase, which is this molecule right here, is going to begin filling in complementary nucleic acid or nucleic bases. Okay, so it's going to come in and it's going to start writing in what they call the 5' to 3' direction. Okay, so it's going to fill this in here and it's going to start writing in this new strand. Okay, now there's also a lagging strand of DNA, which is this top strand up here. This one gets a little bit more complicated, okay, because we have to write in the same direction as here, okay, but we do not have the same mechanism to be able to do that, okay. So what happens is we have these little Okazaki fragments that come in, okay. The Okazaki fragments come in, and we have the DNA get primed by this DNA primase. Once it gets primed by this DNA primase, the RNA primer, these Okazaki fragments come in at little chunks at a time. You can kind of see them back here too. Alright, so they come in at little chunks at a time. DNA polymerase comes through and still makes them bond up. Okay, and then at the very end, DNA ligase works to seal the DNA back together. DNA ligase kind of works like super glue for DNA. Even when we get into genetic modification, we'll talk about how you break down the DNA, insert the DNA that you want to from another organism. So kind of like how we saw with the pigs and the jellyfish DNA, right? So you can actually take a strand of jellyfish DNA for bioluminescence and put it into the DNA for